Hello friends! In this review we will test the special DC-DC converter, which is step up and step down at the same time. Let's connect it to the power source and check how it works. Everything is connected. Let's turn the power supply on. First of all, let's decrease the output voltage to detect the minimum. So 1.2 volts. This is the minimum. Now let's increase the voltage. .32 volts. Let's set the voltage to 5 volts, then increase step by step and see how the car bulb will behave. So we have 5 volts at the output, 12 volts from the power supply. Let's connect the car bulb. 1.7 amps at the input, 3.2 amps at the output. Let's increase the voltage. 6 volts, 7 volts, 8 volts, 9 volts, 10 volts, 11 volts. The power source voltage decreased to 10.1 volts, and at the output this device can provide only 11.4 volts. As to the amperage, it's not more than 5.5 amps. Let's measure the temperature. .62. I can conclude that this device can withstand the load not more than 5 amps, but at the same time, at this amperage, it cannot provide step-up conversion. Let's change this car bulb with this one, which is 20 watts maximum. First of all, let's decrease the output voltage and turn on the device. The input voltage amounts to 12 volts, and now let's increase the output voltage. Let's increase the voltage up to 14 volts. So it's not a problem for this car bulb. Here we have approximately 15 volts, here approximately 2 amps. So this device can freely withstand the load of 30 watts. As to the temperature, maybe this device had not enough time to be cooled. 60. Let's increase the input voltage by 2 volts. So in case of 12 volts, here we have 2.9 amps. And in case of 14 volts at the input, here we have 2.5 amps. Let's decrease once again. The output voltage is the same, so the stabilization function is okay. Let's decrease the output voltage and increase the load. The second one is also 20 watt car bulb, and now let's increase the voltage and see the result. So I try to increase more and more, and the maximum voltage for this load is 14.3 volts. The maximum output power in such conditions for this device is 64 watts. So in view of all the above mentioned, I can conclude that this device is not 8 amp device, not 6 amp device, but maximum 4.5 amp DC-DC converter. But anyway, in case of this current, I would highly recommend to use the cooling solution here. Maybe it's the universal one, because it can provide the voltages from approximately 2 volts to approximately 32 volts, and it's at the same time step up and step down converter, but this device definitely isn't 8 amp device. The frequency in idle mode is approximately 5 kHz, but as soon as we turn on the car bulb, the conversion frequency is 147.3 kHz, approximately 150 kHz. Thank you very much for watching. Till next time.